Math is clean, math's easy when you're doing math with Miss Lee.
This is number 18A and B from page 5 of packet 1 for unit 4. In these graphs, we're applying a phase shift. Just like what you learned at the beginning of the year, if we see something subtracting from the x in the parentheses in the function, that actually slides the graph to the right pi over 4 units. If I use a table, I know that an untransformed sine graph is going to have key points at the axis angles. It hits the middle at key points 1, 3, and 5, the maximum at key point 2, and the minimum at key point number 4. So to apply transformations, in my new table, I would be adding pi over 4 to each of the x values in the old table. And then my y values are going to stay the same. So if I add pi over 4, this is really 2 pi over 4 plus pi over 4, 4 pi over 4 plus 5 plus pi over 4, 6 pi over 4 plus pi over 4, and then 8 pi over 4 plus pi over 4. So those would be my new x values. So if I let each tick mark represent pi over 4, I made 9 tick marks. So here is pi over 4 comma 0. This would be 3 pi over 4 comma 1, 5 pi over 4 0, 7 pi over 4 negative 1, and 9 pi over 4 0. Now if we use the averaging method to find these x values instead, I would set the parentheses, which is x minus pi over 4 equal to 0 to find the location of key point number 1, and then equal to 2 pi to find the location of key point number 5. So adding pi over 4 to solve for x in each of those, I get that the cycle begins at pi over 4 and then ends at 9 pi over 4. So then to find the key points in between those, I would add and divide by 2. To get that 5 pi over 4 is the x-coordinate of key point number 3. So then in between those, I'd have to add pi over 4 and 5 pi over 4 and divide by 2. To get that 3 pi over 4 is the location of key point number 2, and then I would average 5 pi over 4 and 9 pi over 4 to get that 7 pi over 4 was the x-coordinate of key point number 4. So doing the same thing for y equals cosine x plus pi, if I use the table method, then here's a table for y equals cosine x. And then the x plus pi means I'm actually going to subtract pi from each of the x values in my first table. And then the y's would stay the same. So then in my graph, it makes sense to let each of the tick marks represent pi over 2. So here, negative pi over 2, 0, 0, negative 1, pi over 2, 0, and pi 1. And again, using the averaging method, if I set the parentheses, which are x plus pi, equal to 0 and equal to 2 pi, that's a different way of finding the locations of key point number 1 and key point number 5. And then I would average those together to get that the key point between them is at x equals 0, and then average the first and the third to get the location of key point number 2, and then add the third and the fifth to get the location of key point number 4.